Alright, welcome to another maths video. We're going to talk about the sine rule. We've just done the sine rule, just showing you the rule and derived it, got the proof in the sine rule video. So I'm just going to get into some examples now, just to kind of give you guys a bit of headway in terms of what we're doing, how to do a question or two. So starting off, question one. Need to find the length of the unknown to start with. So if I grab this triangle here, and let's say I've got angle of 60 degrees, an angle of 40 degrees, let's say x is here, and let's say this here is going to be 5 meters. Alright, so sine rule. Sine rule says that sine A on A, or I mean in this version here we want A on sine A equals B on sine B equals C on sine C. And in the last video we talked about always getting matching. So A and A are matching opposites. So matching opposites, I'm going to have an opposite pair here. That's pretty obvious. I don't have any other matching though. So if that's A, that's A. I need a match like between here and here, or a match between here and here. Okay. Sides generally worse to find than angles. In terms of angles, I can use my angle sum of a triangle. That's 60, that's 40, that's 100 degrees. So this would be 80 degrees in here. And now I've done that, I do have a second pair of matching. Okay. I should always get a matching pair with an unknown and a matching pair that I know both. Okay, so I know both in this matching pair. I have an unknown in this matching pair here. So setting it up, A on sine A, it's going to be x on sine 40. And then if I have B, remember capitals for the angles, little lowercase for the sides. So it would be 5 on sine 80. And a reminder, sines go together, so sines on the bottom here, sides on top. So solving this, we're going to need to cancel that sine 40 there. Sine 40 is just a number, so sine 80. So we're going to multiply both sides by sine 40 by sine 40. That will cancel, and I get x equals 5 sine 40 on sine 80. And that goes into my calculator. So 5 sine 40 on sine 80. I'm just going to put that in myself. 5 sine 40 on sine 80. And I somehow get a syntax error. Let's try that again. 5 sine 40 divided by sine 80. There we go, that's better. So I've got x is 3.26. And there's no unit stated, so I'm going to state my rounding. It's 3.26 meters, and that is correct to 2dp. Okay, nice, straightforward side lengths question. I'll do another side lengths question, and then we'll do angles. Angles, certainly more heinous. Okay, but secondly, another side length question. So again, we're going to find our unknown. Let's put an x in somewhere. X can go here. This can be 30 centimeters. Angle-wise, this can be 80 degrees, and we'll say this angle will be 40 degrees. Okay, so identifying questions, we're looking for two sides, two angles. Every version of the sine rule is two sides, two angles. Sine A on A, sine B on B. Two angles, angle A, angle B, and two sides, side A, side B. What I've got here, one angle, two angles, and two sides. Okay, so that's pretty good giveaway. We're doing a sine rule question. Okay, I'm looking for matching or opposite pairs. Opposite pairs, I've got 40 and x. I've got 80 and 30. So, trying to find a side. Sides go on top. It's going to be x on the matching pair, sine 40, equals 30 on sine 80. Remember, you can only sine angles. So sine 40, sine an angle, sine 80, sine an angle. Sines together on the bottom. Okay. So multiplying by sine 40. That will cancel. And I get that x equals 30 sine 40 on sine 80. And I put that into a calculator. So 30 sine 40 divided by sine 80, and I get 19.58. Make sure you round. Mine is correct to 2 dp, centimeters to 2 dp. Okay. Matching pairs, two sides, two angles, sine rule. Sides is okay. Angles is where things get a little bit messy. So make sure you know the difference when you're finding sides, when you're finding angles using this rule. So example 3, we're going to find an angle now. Draw ourselves a non-right angled triangle. Let's call it theta there. This can be 20 degrees. This can be 4 meters. And let's say this is going to be 15 meters. Okay. Sine rule, opposite pairs. Opposite pair in here. Opposite pair in here as well. Okay. So I want the version with the angle on top, so sine theta on its matching pair is 15 equals sine 20 on its matching pair is 4. So solving this, I will get sine theta equals 15 sine 40. Sorry, 15 sine 20, I don't know where 40 came from, on 4. That, of course, is multiplying by 15. Note you never multiply the 15 by the 20. It's always 15 out the front. Okay, bad practice. It doesn't work if you do it the other way. So calculating that, 15 sine 20 divided by 4, I get 1.28. Oops, sorry, sine theta. So sine theta is 1.28. That will not work. So what I need to do now, I need to shift sign both sides. Shift signing that answer is going to be an error. Okay, so it's actually no possible value it could be, which is very interesting, I think. Okay. I'll double check I put in the calculator correctly. 15 sine 20, yeah, divided by 4, no dice, not going to work. Okay, there's no possible way this triangle here could work. Interesting. Okay, another example. It's possible you do get that. Most of your examples in your exam will work. Just a hot tip. Let's take example 4 here. If I get myself another non-right angled triangle, so let's say I've got theta in here. I will have an angle of 40 here. This can be 7, and let's say this is 8. So setting up opposite pairs again, that's one of my pairs, that's one of my pairs as well. I'm going to get sine theta on 7 equals sine 40 on 8. So multiplying by 7, I get 7 sine theta. No, I don't. They cancel. Sine theta equals 7 sine 40 on 8. Calculating that. So 7 sine 40 divided by 8, I get 0.56. Okay, and this point, we should be starting to get a little bit cautious, a little bit wary. If we inverse sine both sides here, sine inverse, of course, sine inverse and sine or shift sine will cancel it. So I'll then get theta, just like normal right angle trig. Theta is shift sine of that answer. So 34 degrees and 13 minutes. And if you do that for just your answer, you're not going to get 4 marks. What? You should be recognizing that if you have sine theta equals something, so some decimal here, whatever, you should be getting 2 solutions. Okay, this is the whole reason we did all this ASTC business. The whole reason we do the unit circle. We choose angles. We talked about when we did this, sine theta being the height. Okay, if sine theta is the height, you get it twice. You get theta in here and you get theta in here as well. Sine theta is that height. If you missed this, go back and watch previous videos. Go and have a look at it again. Yeah, you get 2 results. The result that you get, 34 degrees, 13 minutes, is the first result. The other result that you get is 180 minus this. So you get theta is 34 degrees, 13 minutes. Then on your calculator, put in 180 minus that answer that you got, and you should get 145 degrees. So 145 degrees. And 46 minutes. Or 47 minutes by the time you round it. So around that there to 47 minutes. So you get 2 results. Your first result, 34 degrees, 13 minutes. Second result, 145 degrees, 47 minutes. Check both. I can't emphasize it enough. Okay? That height there, ASTC, all that stuff. Okay, sine theta, this should be ringing bells. If it's positive, 2 solutions. That there, alarm, go off, ring some bells. I'll draw a little bell here. It should be ringing because this here bell should be going off. Okay. Now I need to check it's realistic. So if this was a right angle triangle question, we just do shift sine. It works because you get a nice acute angle in there. Okay, so we get a nice acute angle for a Sokotowa question for right angles. It works. That's fine. No worries. But we're now dealing with non-right angle triangles. So we do get the second solution, 145 degrees, 47 minutes. You do need to question, does that work? Okay, so weird enough, you've got to find it. Excuse me. You've also got to go and check that it works. So check that it works. Would that fit in this triangle? If I came along here, so this was 145 degrees, 47 minutes, would that work? And you should be just telling me, well, sir, no, it ain't gonna work. While it's possible to have an angle of 145 degrees in here, that's not gonna work with the 40 degrees here. If I put those two together, I get 185 degrees, 47 minutes. And the triangle's angle sum is not gonna be 185 degrees. So I actually end up with just theta being 34 degrees, 13 minutes here. But I want to see evidence that you've tested that second solution. Theta is 34 degrees, 13 minutes only. You can't just ignore that. You can't, like, if I mark an exam and that doesn't appear at all, you're only going to get part marks. Yes, this is the solution and that only, but part of it is checking that 145-degree angle. Part of it's checking that second solution in there. Okay, let's have another go and see if we can get one that has two solutions. I haven't actually worked out an example beforehand, so this is a little bit risky, but it's good practice to see another example anyway. So this is example 5 we're up to now, I think it is. So just drawing ourselves in a triangle, call that theta. Let's call this 70 degrees here. Let's be a little bit edgy. And this can be 8 again. And say this is going to be, let's say this is 6, might work. Okay, let's say this is 10. And see how we go. So, I would expect this here to be bigger than 70, by the way, because if that's 8 and 70, this should be something bigger. Let's just get into it. So opposites, so sine theta on 10 equals sine 70 on 8. So we get sine theta equals 10 sine 70 on 8. 10 sine 70 on 8. Sine 70 divided by 8 is not going to work. So we're going to get sine theta is 1.17. And you can't sine theta anything bigger than 1. So that's not going to work straight away. Just example searching, going for example 6. So if we have again a non-right angled triangle, if we call that theta, if we have an angle of, let's go 50 degrees here. If this is, so this is 11, this can be 5. So sine theta, the opposite pair there is 5, equals sine 50, angles on top, on 11. So sine theta equals 5 sine 50 on 11. So 5 sine 50 on 11, 5 sine 50 on 11 is 0.34. At this point, again, those alarm bells should be ringing. Okay, sine theta is something positive. You should be checking for two solutions. Shift sign that answer. You're going to get theta is 20 degrees. 20 degrees, and it's going to be 23 minutes by the time you're around. So in case you do miss it, by the way, the sine there. And this side here, that would cancel. This is pretty bad notation too, by the way. If you're doing extension 1, that's why I skipped it. I didn't draw the pink in the first place. Don't do it, don't write it down, but that's logically what you're thinking as you go. Anyway, our first solution we've got, theta is 20 degrees, 23 minutes. Our second solution, we're going to 180 minus our answer again. And we're going to get 159 degrees and 60.62, which is 37 minutes. Check if that works. That will not work again, so theta is 20 degrees, 23 minutes only. But again, I want to see that evidence. Okay, I didn't manage to get one out with two solutions for you today. It's probably enough in terms of examples. If this was, say, 100 degrees, that would work. So if 100 degrees, 150, angle sum of a triangle does leave room for that there. Because I've got 159 here, it's called 160. 160 and 50 is bigger than 180, so that doesn't work. But if I did have 100, that was 100, I would have room for that to work. I would get two solutions. Theta is 20 degrees, 23 minutes. theta is 100, but that's not quite how it is today, which is unfortunate. Anyway, have a go yourself. Make sure you can do the sides questions. The sides questions, very routine. I think, you should be fine with the sides. The angles, obviously a little bit tougher. But watch out for that special case with the angles. Okay, like I said, anything angle-wise, where are the alarm bells ringing? So there's your side question again. Just grab the opposite pairs. It's opposite pair equation in there. Thank you very much. But with the angles, alarm bells ringing when you get something like that. Okay, sine theta is anything positive, always checking for that. If it's right angle triangles, doesn't matter because you're only going to get the acute angle, but we're not doing right angle triangles anymore. You should be checking 2 solutions every single time. Good luck with your own questions. Thanks for watching. I hope you found it helpful.